Alright, hey everybody. So we're jumping into the second part of section 10.2. So we talked about confidence intervals with two proportions the last time. Now we're going to talk about significance tests. So let me start off by saying, just like significance tests did with one proportion, this looks a lot more complicated than it did for confidence intervals. And bear with me, we're going to do it all the way through once. And then I'm going to show you a calculator shortcut that's going to make your life a lot easier. So just bear with me for the first example. So if you've hopefully printed out your notes and you've taken a look at it, this is the basics of what we need to do to show it's still our state plan, do, conclude, still SPIDIC, all of that same stuff. When we're dealing with hypothesis testing, we want to make sure with our state that we've got our parameter, our statistic. We have to write both our hypotheses, our null and our alternate, and then our significance level. So remember, our null hypothesis is always equals, and in this case it's going to always be equal to 0. You don't have to think about your null hypothesis. It's straightforward. For your alternate hypothesis, you have to make a decision as to whether it's less than, greater than, or not equal to. And that's based on the wording in the problem. If it says different, then it would be not equal to, less than or greater than, bigger or smaller, then you use the appropriate sign. And then this one is a 2-sample z-test for P, and that's what we're going to be looking for. You still have, I jumped too far on that one, sorry, you still have to check the same 3 conditions. We're going to be sick of those by the time we're done with this. Still checking to make sure it's random, still checking for 10%, still checking for large counts. At this point with large counts, you can start to shortcut things and write probably less steps than you did before, and you'll see when we get there. Alright, where things get different is in the do section. The general formula is still the same. It's still your test statistic equals your stat minus your null over your standard deviation. But what gets weird is dealing with the different pieces. So when we did this the first time with a 1 proportion, we just went through and proved it's normal. That's why we checked for all of those things up at the top. Since it's normal, we're going to use a mean of 0, so that is still the same. What's a little different now is adjusting for our standard deviation, and instead of plugging in P1 and P hat 1 and P hat 2 into our standard deviation formula, we're going to plug in P hat C, and that's our combined successes or our pooled successes. And so what it is it's the number of successes from the first one, the number of successes from the second, over the total of the first one and the total trials for the second. We're going to work an example in a minute, so bear with me. It'll make a little more sense once we've done it. So jumping to our formula, the statistic is P hat 1 minus P hat 2. That was the same as it was for a confidence interval. Our null is P1 minus P2. What looks different when you get into that standard deviation down at the bottom, instead of P hat 1 times 1 minus P hat 1, now we've got that P hat C times 1 minus P hat C. So if you look at those two fractions, the only thing that's different is that it's N1 and N2 in the denominators. Otherwise, the numerators of those individual fractions under the radical, they're the same. Still show your work. You're still going to draw a normal distribution and shade. Then we have to find our test statistic. Once we have our test statistic, then we can use norm CDF to find our p-value, which is still the exact same as it was before. Norm CDF, lower, upper, mean, standard deviation. So we're going to use all of those. And then the last step, we're going to reject or fail to reject, whether we do or do not have convincing evidence. Okay, so that's mostly the same steps as before. The formulas look a little more complicated. Like I said, for this one right here and for our P hat C, I'm going to show you how to do that in the calculator after the first example, so just bear with me on that. Alright, so let's look at this first one and we'll just work our way through it. According to phys.org, Black and Hispanic females are underrepresented in STEM programs compared to non-STEM programs. A certain university would like to see if this is true for their student population. They took a random sample of 300 STEM students and found that 12 were Black or Hispanic females. A separate random sample of 500 non-STEM students had 75 Black or Hispanic females. Do the data provide convincing evidence that Black and Hispanic females are underrepresented in STEM programs? Use a 5% significance level. Okay, so up at the top on the front, one of the things I said was before you start, it's not required, but it makes your life so much easier if you go ahead and pool all of your information together. So all the stuff we got out of there, so we've got a bunch of data for STEM students and a bunch of data for non-STEM students. Alright, so for the STEM students, that's going to be P hat 1, and it would have been 12 out of 300, which gives us 0.04. Right, the other thing you're going to need to know out of that, so our N1 is 300, and what we need is our successes, and we're going to use X for that, and that's just the number of times it was true, so in this case it was 12. Alright, then for non-STEM, that's going to be my P hat 2. So it's going to be 75 over 500, which is going to give us 0.15. N2 is 500, and then our number of successes is the number of times it was true, so it was 75. That's all the information we need to fill out everything else. So if you take the extra 30 seconds at the beginning and just write it all out, you've got it. So when you get to different steps, you don't have to do weird separate calculations off to the side. Alright, so our parameter is going to be P1 minus P2, like always. And we just have to describe what this is. It's the true difference in proportions of Black and Hispanic females in STEM and non-STEM. Alright, we figured out what our P hat 1 and P hat 2 were already. So P hat 1 was 0.04. P hat 2 is 0.15. When we subtract that out, we're going to get negative 0.11. Alright, so our null hypothesis is always going to be P1 minus P2 equals 0. Period. You don't even have to think about it. Alright, so now what we have to do is go back and look at the problem and figure out what this means. So it says, does the data provide convincing evidence that Black and Hispanic females are underrepresented in STEM programs? So if they're underrepresented, that would mean that there would be less of them. They would have a smaller proportion. Well, that's my P1. So if I do P1 minus P2, and I'm looking for P1 to be smaller than P2, when I subtract, I should get a negative number. If I do a small number minus a bigger number, that's going to give me a negative. So that would be less than 0. And then they tell us to use an alpha of 5%, which is 0.05. So that's what we're going to be testing our p-value against. Alright, so that's the state. Next up is the plan. Name of this one is a 2-sample z-test for P1 minus P2. Alright, now we got to go through and check all of our conditions. So first, for random. In the problem, they said that they took a random sample for both of STEM students and non-STEM students. So they were both random samples. Alright, for 10%. So they're saying that for this to work, there would have to be 300 would have to be less than 10% of all STEM students. and then 500 would have to be less than 10% of all non-STEM students. Alright, and then for large counts, I'm just going to go down in order. If you really want to write it all the way out with the formulas, you can. It's not required. I would at least write the multiplication out though, so if you wrote your multiplication correctly and then you just mashed the buttons wrong in your calculator, you could still get partial credit. Alright, so for this one, the first one, it was 300 times 0.04, and that gives me 12, so that's good. The next one is 300 times 0.96, and that's 288, so that works. Then we've got 500 times 0.15, and that gives us 75, so we're good there. And then the last one is 500 times 0.85, which is going to give us 425, and so that's good. So all of those are greater than or equal to 10, so we're good. So we passed our random sample, we passed our 10%, and we passed all of our large counts. So we can go ahead and move on and do the test. Alright, so the mean is always going to be 0. You just need to know that. I mean, that's what we use when we would type it in Norm CDF. We would do our lower, our upper, and then 0 and 1. So that's fine. Now what we need to find is our pooled proportion before we can plug into our formula. Alright, so this is why I had you write down up at the top. We needed our successes. So the successes for P1 was 12. Our successes for P2 was 75. P1 was out of 300. P2 was out of 500. So that gives us 87 over 800, which works out to be 0.109. So that's what we have to use when we plug into our formula. So we're going to use that. That's our P hat C. Okay, so this scary looking beast is our formula. Like I said, I'm going to show you how to do it by hand. After this, you can use the calculator, and if you use the calculator, you don't have to write the formula. So just do it once so you can see it, and then after that, the next video, I'll show you how to do it with the calculator. Alright, so P hat 1 minus P hat 2, we found that already. It was negative 0.11. Alright, and then we're assuming our null hypothesis is true. So go back up and look at your null hypothesis. Is P1 minus P2 equals 0? Well, this is asking what P1 minus P2 is. So it's going to be 0. Alright, in the denominator, we'll have some ugly fractions, just roll with it. Alright, so P hat C is 0.109. 1 minus P hat C would be 0.891. And that's over our first sample, so our first sample size, our first n. So it was 300. Then we're going to come over here and do the same thing. The top is exactly the same. 1.109 times 0.891, and now it's over the second sample size, which is 500. Alright, I'm going to ask you to trust me so I don't have to bust the calculator out, but that ends up giving us our Z of negative 4.838. Alright, and that can actually jump down here. Alright, so now we need to draw our picture. I'm doing the standardized graph because I don't have an insane amount of space here. If you need to draw the unstandardized graph, you can. Just get with me later and we'll talk about that. Alright, so then we want to go through and z is negative 4.838. And we need to go back now and look at our alternate hypothesis. So our alternate hypothesis was less than. So we would be shading to the left. If our alternate hypothesis was greater than, we'd shade to the right. And if our alternate hypothesis was not equal to, we would shade both sides. This is just less than though, so we don't need to worry about that last part. Okay, so plugging into our calculator. We're going to plug in what we know, and we're going to do our norm CDF. So we've got our lower bound would be negative 9999. Our upper bound would be negative 4.838. Our mean is 0, and our standard deviation is 1. I meant to label that up here, and I did not. So we're here. Alright, so we're going to do menu, 5, 5, norm CDF. So if you're using the Inspire software, it's going to default to a negative infinity, and that is totally fine. If you're using the regular calculator, just do the negative 9999. We may be off by like a 10,000th place, but that's totally fine. Our upper bound is going to be, there we go. Our upper bound is the negative 4.838. Mu is 0, standard deviation is 1. And so we end up getting a really tiny p-value. If you notice that scientific notation, so that is e to the negative 7th. So that means we have 6 zeros in between the decimal and our first number. So our p-value ends up being, let me get that back. So 0.000000657. Alright, so y'all tell me, is that bigger than 0.05 or smaller than 0.05? Alright, so our p-value works out to be 0.000000657. That's, y'all tell me, that's definitely smaller than 0.05. So if it's smaller, then we can reject our null hypothesis, and we have convincing evidence. So we reject the null hypothesis. Because our p-value is smaller than our alpha. Alright, now when we say we have convincing evidence, we have to make sure we go back and state exactly what we have convincing evidence of. So we were proving that, is asking if there was convincing evidence that Black and Hispanic females are underrepresented in STEM programs. And yes, we do. Okay, so I promised you a calculator shortcut. So I clipped these out of the calculator steps at the back of your textbook in the appendix. So we're going to work through it with our data from the problem we just had, but this is working, and the numbers in this are working for one out of your textbook. It's an example from page 622. All right, so let's talk through this one. All right, so first thing we need to do is we need to get to our calculator scratchpad. We're there already. All right, we want to hit Menu, Statistics, which is 6, Stat Test, which is 7, and we want to prop z-test, because we're doing 2 proportions, all right, which is number 6. All right, remember that chart I had you make up at the top? This is a part of the reason. It's real easy if you make that chart to just go boom, boom, boom all the way through. All right, so for the first one, we had 12 successes out of a sample of 300. The second one was successes were 75 out of a sample from 500. All right, this one's actually really cool. I love this. So your alternate hypotheses are already there. You just have to select it. So we had P1 would be less than P2. All right, and then you hit OK. It's going to spit out some scary looking stuff here. We don't need all of that information, but we need some of it. So first off, it gives us our Z, which is our test statistic, which is the negative 4.838. It gives us our p-value, which was the 6.56 times 10 to the negative 7th. It goes ahead and actually calculates your p-hat1, your p-hat2 for you. And I think that's all we need for that one. So if you're using this one, what you need to write down is you need to write down that in the do step, when you get to the general formula, you need to say that you're doing a 2-prop z test, and then you need to make sure that you write down the z that you get out of it, and you write down the p that you get out of it, your p-value. And as long as you write those 2 things down, they will give you full credit, which is awesome, because then we don't have to deal with all the crazy square roots and fractions in our calculator and run into chances of messing that up. So for the next 2 problems, we'll go through and work them using the calculator. I'm not ever going to make you do the formula again. That being said, if you really want to do the formula, knock yourself out, but I think this is much faster using the calculator. Okay, that's it for me on this one. We'll do the second video. We'll cover examples 2 and 3. Thanks, y'all. Have a good night. Bye.